All right. So the last topic I want to talk today is about trusted intermediary system based on secret key cryptography. And here we talk about the following scenario. We have a node or a hierarchy of nodes. Uh, which bear a function of key distributions. So for key distribution. And well, as such nodes are called key distribution centers. Centers. KDC. And the scenario we are considering, so we have, say, a corporate network. And to each to this network, we connected, say, printers, connected file systems, um, web servers, well, any kind of servers, and lots of PCs. PC 1, PC N. And this KDC stuff is also connected to the network. So it's a physical server. So this KDC is a physical server, very protected piece of hardware that sits in the same corporate network. So it's physically secure. It is always online. Online. And and each node in the network, each node, is given one master key. Which is used for communication between user I to KDC. And how to get this key? So maybe, I mean, the very first time you're getting an account. So that was how it worked previously, anyways, in at LTU. So you go to your sysadmin and you get a login name and a password on a piece of paper. So this is at this moment they created a record and created a secret key for communicating to the system. And there are two concepts involved in this authentication process. So two concepts. A concept of a ticket. So I give you an example. So for uh, for node or here user B, not node. Let's use the name user for user B. So a ticket to user B is something encrypted. So this plus is encrypted with a key B. So this is the master key. No, known only for the KDC and the user. And here inside, so you normally say, okay, so uh, this is a ticket for communicating to A and use key like this. So it's an encrypted session key to communicate to another device or another user. So, and the second concept is something which is called uh, ticket uh, granting ticket. Ticket granting ticket. So ticket granting ticket is also is an encrypted information, so TGT, and this information contains also of a session key of communicating to a certain user as a user session key, and it is signed with the secret key of the KDC. KDC, which is known only to the server. So it will never be decrypted by anybody else, but only KDC. So just to see how it all works together, so let me finish this class by presenting the following diagram, and then tomorrow I will go through it once again to complete the story. So we have two users, user A and user B. So what happens, and here is the software plane. So software. And here we have our KDC, key distribution center. So user A wants to communicate to B in a secure manner, so authenticated manner. So say a service request. So A wants to communicate to B. And it sends to KDC also this thing, ticket granting ticket. We say, okay, so this is A, and this is the session key to be used to communicate to me. And that was established the very first time the user entered the password. So, and this tab, this ticket granting ticket, allows KDC decrypt the session key without keeping it in a database, right? And then it also sends authenticator, authenticate info. So, nonce. So what KDC does, so this nonce is normally a timestamp. So just uh, um, uh, to be sure that the request is fresh so that nobody else can reuse it. So this thing is communicated to KDC. So what happens is, so this KDC decodes the session key to A. It generates session key to be used for communication between A and B. And then it replies. So here it replies the following information back to A. So B, so you want to communicate to B. So this is the key you will use to B. And I include a ticket to B. And I encrypt it with a session key of A that I decoded previously. So this ticket B over here, I just remind you from the previous page. So this ticket B is the encrypted record like this. So A wants to communicate with you. It will use KAB as an encryption key, and I encrypt so this thing is encrypted with master key of B, so which is known by KDC. And that's it. So next time A wants to communicate to user B some information, so it encrypts the information and it includes with the KAB, and it appends the ticket to B to this communication and sends it over to B. And user B, by being able to decode the ticket, knows for sure that A is authenticated by KDC. So the overall scheme for trusted intermediary system using secret key cryptography. Let me see if you have immediate questions now, and tomorrow I will go through the last through this schematic again as a repetition. Well, if not, then officially I stop recording, but I'm still here. So if you want to ask anything, so please. So